Okay, we remember our chain rule, dy dx equals dy du, du dx, where we can do u substitution. So here we've got this sine thing here, so we're thinking that as sine u, and then we're going to get clearly, well, okay, let's just do it. U equals set y equal sine u, where u equals, so dy du equals, and du dx is 3 plus 2 dy dx. So when we're thinking of differentiating that first term, we're applying that concept dy du, so that'll be cos u du dx. Just because I'm going to put that out the front. 3 plus 2 dy dx. You know what? You don't, we're big boys and girls now, got big boy pants on. Don't really need a lot setting out. It's just a pretty straightforward rule, isn't it? Okay, and then we're differentiating the 2x, and then with the 2y, dy dx equals 0. Clearly we're still just looking for this dy dx equals, but we've got two of them, so we're going to have to expand this bracket, so that's going to be 3 cos plus 2 cos let's factor. So 2 cos plus 2y dy dx. Yep, okay. Then we want to get these other terms that don't have a dy in it to the other side. So let's go and pretty straightforward there. Sorry, I left a big gap there from the question, but anyway. So, why am I having such a hard time writing an x? Minus 2x all on okay, there you go. It's just a chain rule and then factorising. I'm sure that shouldn't be a 3. I'm sure that should be an E. Typo in the question. So that's E to the U. We've got two chain rules. Okay, so when we're differentiating E, the derivative of E stays down there, and out the front comes the derivative of what's in the power. So that would be 1 plus dy dx plus, okay, what's the derivative of y? Because we know we're going to get, actually that's going to be a minus, isn't it? Because that's going to go to a minus sine y, and the derivative of y comes out the front, which is, that's the chain rule, and then just some implicit 2y dy, then just implicit differentiation there, that's a nice easy one. Okay, we've got dy dx's everywhere, but I've got a bracket here, so I'm going to have to go, well that's e to the plus e to the y dx minus sine y dy dx minus 2y dy dx. Let's factor out all of our dy dx's. That's that one. And minus 2y. And we're going to get that one to the other side equals minus e to the. And then we're going to just flip that bracket. I don't really want that negative there, so I'm going to make that a positive. And then when I bring this bracket over, I'm going to swap all the signs. So let's just go 2y plus sine y minus e to the x plus y. There you go. Not huge, a couple of lines and it pops out. Is there another one? Oh my gosh, there's one more, sorry. Longish video. We've been differentiating logs for a while now, so we just know through the chain rule we're going to have a 2x plus 3y on the bottom, and the derivative of that is going to go on the top, which is going to be 2 plus 3 dy dx plus 4 dy. Okay. That's a little bit yucky, isn't it? So we've got a big bracket there in the denominator, which is really stuffing up getting that out by itself. So we're going to have to multiply everything by this bracket here. 2 plus 3 dy dx. So that bracket times 4 will be, and now that bracket times that. So minus 10x minus 15y, and then times 0 is 0. So that's flushed out everything onto one line without any brackets. So let's just factorise our dy dx. There's a 3. There's a minus 10x and a minus 15y. Then we're going to get all these other ones that don't have dy dx connected and flip them to the other side. And then I don't really want all those negatives, so how about factor out the negative and then make everything over here just put that negative into that bracket. There we go. Okay, again, it's different, it's new, but it's not really that hard. You just got to do some practice and they just fall out pretty quickly. Do every single question if you can.